Assalamu alaikum, my dear students. I hope you people are doing great. Today I am going to present the second chapter of general maths, which will basically focus on some definitions and explanations, as well as I will solve some other example problems. What is actually universal set? All sets are under a specific set. Say for example, there are some sets which is a mother set. This mother set is basically known as universal set with respect to all other sets. So I would like to give some examples, then it will be very much clear to you. A is a mother set which contains the elements x, y, z, p. Okay. And there are some other sets, say for example B contains x and y. C is another set which contains z and p. D is another set which contains x and z. All these three sets, I mean B, C, D, all these three sets are subset of A. Then A will be defined as the universal set with respect to B, C and D. I mean A is the universal set of B, C and D. Okay. And complement of a set. Complement of a set, say for in this example I can define the complement of a set. All the subsets, I mean A has three subsets here, B, C and D are the subsets of A. And the complement of set B would be the universal set delete these subsets. Say for example, B complement would be here. It would be better if I term the mother set as U. U would be better to define the universal set. So U is the universal set which contains the elements x, y, z and p, and B, C, D, all three are the subsets of U. So I can find out the B complement very easily. It is basically difference between this universal set and the set B. I would like to find out the B complement, then it would be U delete B. So U means x, y, z, p. Delete B means x, y. Therefore, what would be B complement? B complement would be, since all these two elements are common, so the B complement would be z and p. And what would be C complement? Universal set minus the subset C. So universal set means x, y, z, p. Delete C means z and p. Therefore C complement would be ZP are common elements, so XY will be the C complement. Similarly, what will be the D complement? Actually, you will find all the definitions from your book, so I would like to give some explanations by using these examples so that you get clear conceptions of universal set or complement of a set. Okay. So what would be D complement? Would be universal set minus subset D. Therefore universal set equals to x, y, z, p. Delete D means x, z. Therefore D complement would be x and z would be omitted. Therefore it will be y and p. Okay. I hope these are very much clear to you. Now I would like to solve an example problems. Example problem number 7. If a universal set U equals to 1, 2, 3, 4, 5, 6, 7 and A equals to 2, 4, 6, 7, B equals to 1, 3, 5, then determine A complement and B complement. Exactly the similar problem, the similar demonstrations I have given earlier, so it will be very much easier for us to solve this problem by using that demonstration. Here it is given U are the universal set that contains the elements 1, 2, 3, 4, 5, 6 and 7. Okay, and A is a subset of U which contains the elements 2, 4, 6, 7. Therefore, as per the definition of a complement set, we know that a complement of a set would be defined as the difference of the universal set and of that set. So the complement of A would be denoted by A to the power C or A superscript C, and it will be termed as universal set delete the actual set. So universal set means 1, 2, 3, 4, 5, 6, 7. Delete the set A means 2, 4, 6, 7. Now try to find out the difference or to delete the items from the first set. We have to find out the common elements, 2, 4, 6, 7. These elements are common. Therefore, the remaining elements will be 1, 3, 5 only. This is basically a complement of A set. Okay. Similarly, in the B subset, there are some elements which are basically 1, 3, 5. 1, 3, 5. Okay. So as per the definition, I would like to find out the complement of B set. Then it will be denoted as B to the power C or B superscript C, and will be termed as universal set delete the set B. So universal set means 1, 2, 3, 4, 5, 6, 7. Delete B means 1, 3, 5. So try to find out the common elements 1, 3, 5. 1, 3 and 5 are the common. So the remaining elements will be 2, 4, 6 and 7. This is basically the complement of B set, okay, which is denoted B, C. Okay, I hope this is also very much clear to you. Now I have to define union of sets. If two or more sets are, if a set contains the elements of two or more sets, then that set will be defined as the union of these two or more sets. Okay, say for example, example will define the problems or define the sets very much easily and very much clearly. Okay, so I would like to give some examples always. So the union of sets. Set A contains the elements 1, 3, 5, 7. And the set B contains the elements 3, 7, 9, 10. Now I would like to find the union of sets A and B. I would like to use the symbol U as the union. So the union of set A and B will be denoted by A union B, and the items will be, first of all I would like to write down the items 1, 3, 5, 7, then union 3, 7, 9, 10. Okay, you see at the initial stage I would like to identify the common properties. I would like to identify the common items. You see here 3 and 7 are common to both the sets. So other than these, all other items will be written exactly, and since these two items are common to the both sets, I will just write down one time. I will not repeat these items. Okay, so what will be 1, 3 is common to both, so it will be written only once. 5 and 7 is common to both sets, so 7 will be written only once. And then you see 9 and 10. In this set you will find that all the items from these sets A and B are included in this set. There is no items that are excluded. So this is basically the union of these both sets A and B, and this is denoted by A union B. So what are the definitions saying? If the elements of two and more sets are joined together, okay, you see all the items and all the elements of this set A and B are joined together, and there is no repeated items. So this is basically the A union B, or A union, or the union of both sets A and B. Find the intersection of sets. Intersection of sets is exactly opposite of the union of sets. Intersection of sets, if I would like to define the intersection of sets, then it will be like when I will take just the common items from two or more sets, then it will be known as the intersection of sets. In the above examples, I would like to find out the intersection of A and B, then it will be written as A intersection B will be, see, you see there are only two common items from A and B. Here 3 and 7 are the common items. So A union B, first of all I have to write down this 1, 3, 5, 7 intersection 3, 7, 9, 10. Now since this is intersection, so I have to take only the common items. So 3 and 7 are the common items. So what will be the intersection? Intersection will be 3 and 7. Okay, therefore A intersection B will be 3 and 7. I hope this is also very much clear. One more term that is known as disjoint set. If there are two or more sets which have no elements common, okay, then these two sets are basically known as disjoint sets to each other. So for example, A is a set of element 1, 3, 5, 7, and B is a set of element 2, 4, 6, 8. Then you see there are no common elements to the both sets A and B, therefore A and B are disjoint to each other. Okay, you see there are no common elements to these both sets A and B, therefore A intersection B equals to empty. Okay, if A intersection B equals to empty, then both the set A and B are said to be mutually disjoint or disjoint to each other. Okay, now I would like to solve a problem from the examples, which is example problem number 8. Example problem number 8. If C equals to 3, 4, 5, C equals to 3, 4, 5, and D equals to 4, 6, 8. Then determine C union D. Okay, C union D would be 3, 4, 5 union 4, 6, 8. You see, there is only one element common to the both sets, that is 4. So only 4 will be used once. Say for example 3, 4 is common to both, so it will be it won't be repeated, it will be used just once. Okay, 5, then 6, 8. This is basically C union D. All the items are taken except the repeating items. The repeating items will be taken only one time. Okay, 4 are repeating to the both sets, but I have taken only taken 4 for only one time. Okay, this is basically the C union D. Now I would like to solve the problem number, example problem number 9. Example problem number 9. If P is a set of element x belongs to natural numbers, where x is greater than 2 and less than or equals to 6, and okay, let me write it down. It's given that P is a set of element x where x belongs to all natural numbers such that x is greater than 2 and less than or equals to 6. Now I would like to break down this set into details by I would like to find out the elements of this set by breaking down these properties into details. Okay, since x are all natural numbers, x belongs to all natural numbers, but there is a limit. Okay, so the numbers can be, since it is greater than 2, so it can be 3, 4, 5, 6, but not greater than 6. Therefore P equals to 3, 4, 5, 6. And there is another set Q, where Q is a set of element x belongs to all natural numbers such that x is even and x less than equals to 8. There are two properties. You have to break down these two properties into details and combine these properties by using the AND conditions. Okay, as per the first conditions here, even numbers can be 2, 4, 6. Since x belongs to all natural numbers, so x is even, therefore x can be 2, 4, 6, 8, 10, 12 or something like this. But if I implement these conditions and these range, then I cannot take more than 8. Okay, therefore here you can write it like this. Here x can be 2, 4, 6, 8. Okay, now the set would be Q equals to 2, 4, 6, 8. I cannot take the elements, I cannot take the even numbers that are greater than 8. Okay, now I have to find out the P intersection Q. Therefore P intersection Q means P means 3, 4, 5, 6, intersection Q means 2, 4, 6, 8. So since it is intersection, so I have to take only the common elements. What are the common? 4 is common to both sets, 6 is also common to both sets. Is there anything else? 3, 5, no. Therefore the common elements will be 4 and 6. P intersection Q would be 4 and 6.